we're pulling a crate to the right with our force of pull, giving it an acceleration of 4 meters per second squared, and we want to know, well, how much friction is acting on this thing? So again, we're going to use Newton's second law. Now we're going to have to ask ourselves, well, which way is this accelerating? It's accelerating to the right, the direction I'm pushing it. It is not accelerating up and down. That would mean that the normal force and the force of gravity are equal to each other. They are balanced, but we're not really too worried about that in this problem. So now we're going to use Newton's second law to figure out what must that force of friction be. So I set up my equation. All the positive forces, which is force of pull, minus my negative forces, which is force of friction. And that's going to equal mass times acceleration. Now we're trying to solve for this force of friction, so I want to get it all by itself. So I'm going to add it over to the right side, giving me force of push equaling ma plus the force of friction. And now I'm going to get rid of ma, so I'm going to subtract that over to the left, and that's going to give me force of push minus ma equals the force of friction. Now I can plug in my numbers and solve for what my force of friction is. Force of push is 120 newtons, that was given in the problem. The mass of this block, also given in the problem, is 8 kilograms. And the acceleration is 4 meters per second squared. So when you plug that into your calculator, what you should get is a friction force of 88 newtons acting on the box.